This set of notes covers implied domain. In this case, we're going to find the domain of a function. The domain of a function can be described explicitly or given to you directly, or can be implied implicitly by the expression used, used to define the function. The implied domain is a set of all real numbers for which the expression is defined. For instance, the function f of x equals 1 over x squared minus 4. We know that this function cannot have a domain of all real numbers because there are some values for x in the denominator that will make the denominator equal to 0. So what we have to do is we have to take this function's denominator, we have to set it equal to 0 and find out what those values are. So as you can see here, I've set this denominator equal to 0. I've added 4 to both sides of the equation. I get x squared equals 4. Then in order to solve for x, I need to take the square root. When I take the square root of x squared, I'm going to get two solutions, one positive and one negative. So I get a plus or minus square root of 4, which is plus or minus 2. So that means that if my x value up here is 2 or negative 2, I'm going to end up with a 0 in my denominator. And this function is undefined when the denominator has a 0 in it. So in that case, we have to keep those two values in mind when we're writing our domain. The next thing I'm going to do is write out my domain. All right, so here I've written the domain. We begin with the negative infinity, and remember that infinity, you can't enclose infinity in brackets, so it's going to be an open parenthesis. We have to stop at negative 2 because we can't not include negative 2. And since this is not included, we have another open parenthesis. Then we also have to show that we're going to include anything between negative 2 and 2, but not including them. So that would be negative 2, comma 2 with open parentheses. And then the last set, we're going to show that we're going to start back at 2 again, but we're not going to include it, so it's open parentheses, and we're going all the way to infinity. Again, open parenthesis. And this is how you would write the domain for this function right here. In the next example, you just simply need to make a list of all your x values. Since this is a discrete function, it's not continuous. So we're not going to have any values in between these values for x. It's just simply these values for x are going to be our domain in this case. And we would write this one in set notation. So far we've written a domain in interval notation and set notation. So there's different ways that we can write domain. Most of the time we're going to use interval notation because most of the time we're working with continuous functions. Even with piecewise functions, we're going to use interval notation. We are going to delete this volume of a sphere example. We're not going to do that one. In this last example, we see that we have h of x equals the square root of 4 minus x. Well, if you remember from Algebra 2, a square root function cannot have a negative number in the real number system inside the radical. So because that number can't be a negative number, again, we need to set that whatever's underneath the radical equal to 0, or actually less than 0, to see what values x cannot be. All right, so I have set 4 minus x squared less than 0. I am solving for x, so I subtract 4 from both sides of the inequality. Then when I divide by -1 to get rid of this negative sign, it actually ends up flipping my inequality over to greater than. So I get x squared is greater than 4. Now I take the square root, and when I take the square root, I get two values for x, plus or minus 2. So x is greater than plus or minus 2 is going to be the values that x cannot be. Because if x is any value greater than 2 or negative 2, then this value right in here will be a negative number. So we can only use the values between -2 and 2 in this particular function. So now I'm going to write the domain and show you what that looks like. So in this case, we're going to keep the -2. Since we're going to keep the -2, we're going to write that with a bracket. And right here, we're writing this with a bracket. And all the way between -2 and 2. So after the 2, of course, we're going to close that with a bracket. So we can include these two values and anything in between these two values, but we can't include anything outside of those values. All right, so 3 rules to remember. Rule number 1 is to determine if the domain is continuous or discrete. Rule 2, determine if the domain is a measurement or absolute value. 3, also determine if there are any values for the domain that would make the function undefined. And that's it for this set of notes. Good luck this week on your test. Be looking for the review on the test on Wednesday night.